Hi everyone, and welcome back. We are now in week 12 of the course, so we're really getting close to the home stretch here. We just have a couple more of these, and then I think before we all know it, the semester will be over. Which I'm sure is at least as exciting to you guys as it is to me. Not that I don't love you. So this week we are going to be talking about how to compare two means. So, quick recap, last week's lecture was all about how to do a hypothesis test to see if the population mean is likely to be equal to some particular value. And that's useful sometimes, every once in a while there's a reason to test whether a population value is likely to be equal to some benchmark. But it's not as useful and as widely used as the one that we're going to meet today. And specifically what we're going to do today is learn about a hypothesis test that lets us look at means from two samples and make a comparison between two groups that would apply to the whole population. So examples of questions that you could answer with a t-test like the one we're going to talk about today would be, do male police officers use more force than female police officers? So you could take a sample, you could compare the male officers in the sample to the female officers, and then use that sample to try to learn something about whether among police officers in general, there's a difference in use of force, by gender. If we're talking about courts, so do sentence lengths depend on race? Do black defendants get harsher sentences than white defendants? And it would be the same idea where you could take a sample of sentences or cases and then compare outcomes among the two groups in your sample and then see if, in the population of people who are getting sentenced as a whole, is there a difference by race? And final example here, do drug treatment programs in prisons work? So just giving you police, courts, and corrections. So if you have a drug treatment program, you'd have a group of people who take the program, a group of people who don't take the program, and you could compare the outcomes for those groups, and that could give you information about whether, among people in prison overall, having a drug treatment program is beneficial. So with all of these, we're using samples with two groups in them to try to learn about differences among those groups and on some dimension in the population as a whole. And these are just a couple examples, that I throw on here, but if you think about it, there's really a lot of different applications for this in criminal justice and then in the world more broadly. So now I'll get into the weeds a little bit more of hypothesis testing for two means. And I'm going to just use the first example I had on that slide, which would be use of force among male and female police officers. So when we do a hypothesis test, we're always going to start out by writing out our hypotheses. So if you remember back to the last lecture, we had that general format for hypothesis testing where you come up with hypotheses, you find a test statistic, and then you decide whether to reject the null hypothesis. So our first step here, and the first thing I'm going to talk about, is just the format of the hypotheses. I'm also going to go through the steps more specifically on a later slide, and then of course go through an example where we test it with a concrete example in the document camera as well. So when we're talking about two means and testing differences between means, the real question we have is whether two groups, whatever they might be, have the same mean level of something in the population. So if we're talking about male and female police officers, we're interested in whether among police officers as a whole, so just the whole population of police officers, being male or female has anything to do with how much force people use. So we're interested in whether the amount of force used by male police officers is the same or different from the amount of force used by police officers. So one way that you can write hypotheses in a hypothesis test like this would be to format them like this. So I'm showing you the equation formats for these, and I'm going to show you a slightly different version in a second with both the equations and the words. But one way that you could do this would be to make your null hypothesis the hypothesis that the overall mean for men is equal to the overall mean for women. So in other words, the average number of force incidents recorded for men would be the same as the average number of force incidents recorded for women in the population as a whole, or however you want to measure use of force. So that's your null hypothesis. And if we find evidence against it in our sample, then we would have evidence in favor of our alternative hypothesis, which is, whatever's left over if you rule out the null hypothesis. So your alternative hypothesis in this example would be that the mean amount of force used among male police officers is different or not equal to the mean amount of force used by female police officers in the population as a whole. In formally testing these hypotheses, though, we will usually be writing the hypotheses out in a slightly different way. And the way that we're going to write them is going to be reflected in the sampling distribution that we'll be using to do the hypothesis test. But before I get ahead of myself there, another way of writing those hypotheses would be to just change it over so that instead of having the overall mean for men be equal to the overall mean for women, for your null hypothesis, you could say that the overall mean for men minus the overall mean for women is equal to 0. So if you think back to algebra, all we've done here is subtract, the mean for women from both sides of the equation. So on the right hand of the equal sign, we get a 0, and then on the left hand, we have the mean for men minus the mean for women. But if you think about it too, it should make some amount of intuitive sense. If you subtract one thing from another thing and get 0, you know that those two things have to be the same. So it's just a different way of writing out that first hypothesis. And you could also say this in words by saying that the difference in use of force between male and female police officers is 0, or that there is no difference. So the difference in the mean levels of force used by male and female police officers is 0, and in other words, there's just no difference between those two means. The alternative hypothesis then is just that, but instead of saying that it's equal to 0, we're saying that it's not equal to 0. So we're saying that if you were to subtract the overall mean use of level of force used by female police officers from the overall amount of force used by male police officers, you'd get something other than 0. So again, if you just think about that, if you subtract one thing from another thing and it's 0, it means that they have the same value, and if you subtract one thing from another thing and it's not 0, it means that they're different. And so then you could also say this in words by saying that the difference in the mean levels of force used by male and female police officers is something other than 0. So there's some difference in those means. And so these are, again, hypotheses about what's going on in the population. And anytime we do hypothesis testing, we'll be using our null hypothesis as a model for what the population might look like. So we're going to imagine a world in which the amount of force used by male and female police officers is exactly the same. And then what we're going to do is we're going to use our sample and see if we have evidence that can either say that that's not likely to be the case, or whether we don't have enough evidence to rule out that possibility. And to do the hypothesis test specifically, we'll be using a sampling distribution for differences in means, which looks a lot like the sampling distribution for means that we've met already, but it has a slightly different format to it, and you would plot your samples on it in a different way. So I'm actually going to go over to, first I'll describe it, then I'll go over to the document camera. So the sampling distribution for differences in means shows you the possible differences that you could get between your sample means and the probability of getting each one. So instead of plotting sample means themselves and the probability of getting each one, we're looking at the possible differences between sample means and the probability of getting each difference. And it'll take the shape of a t-distribution, just like we had last week when we were just looking at regular sample means. So t-distribution, very similar to a normal distribution, just slightly different shapes to account for the uncertainty of not knowing what the standard deviation of the variable is in the population. All right, so with that, I'm now actually going to head over to the document camera and show you what this sampling distribution for differences in means looks like, show you how you would plot some different sample values on there, and then we'll come back and talk about how to use it for the t-test.